Good morning. You are welcome once again to Stark Power Technology Limited. My name once again is Stephen Adeniyi, your friend in the School of Power Technology. We are in the business of power supply, renewable energy, hydro, wind and solar, power supply from the national grid, electrical installation in building, and power electronics. Yes, let's move straight away to our next section, which is solar panels and solar charge controllers. Solar panels and solar charge controller. Yes, solar panel is one of the accessories that we need in solar power supply, and likewise the solar charge controller. Yes, solar charge controller. It is an accessory that controls the inflow of DC power, the inflow of sun power in form of DC into our battery, and it controls it in such a way that it won't damage our battery bank. It controls when the solar panel generates power from the sun. Yes, through its terminals, positive and negative, it gives it to solar charge controller. It is in form of a charger, solar charger. But what it does is not to charge alone. It collected or accept current in form of DC from the sun, then boost it. It boosts it, that is, it amplifies it. If it is getting like 2 amp from the sun, it can amplify it to 3.5 or 3. It depends on the type of controller. Then now use it to charge the battery. It uses it to charge the battery. Then when the reason why it is solar charge controller, when the battery is full, it will stop giving the battery the power that is being received from the sun. And it also amplifies the power that is being gotten from the sun. So we can see that the solar charge controller does like 3 things now. It charges, it amplifies, then it controls the flow of electron or the flow of power into the battery. When it senses when the battery is full and stop on its own. So this is an example. This is an example of solar charge controller. This is an example of a solar. You can see solar charge controller. This is an example of an external solar charge controller. This is the port. This port here. This, you can see the icon of a solar panel. This port and this port. This is where our solar panel positive and negative will come in. This one is the positive and negative of battery, while this port for DC load. Maybe we have DC bulb or DC fan or anything that I want to use. So this is the typical charge controller, and this type of charge controller is 10 amp. This controller is you can see from the label It's 1224 volts, 10 amps. So solar charge controller is rated in amps. It's rated in amps. It can be 10 amps, 15 amps, 20 amps, 30 amps, 60 amps, 100 amps, 120 amps. That is the special. You will get familiar with the specification we have in the market, or the specification manufacturers by manufacturers. You will get familiar with it as we proceed, as you are practicing on site. Then you will also look for it has different voltage adaptation as specified by the manufacturer. Some can adapt with 1221 volts, some can incorporate 12, 24, 36 volts. We have some the capacity that has the capacity to incorporate 12, 24, and 48 volts, and so on. So the way this solar charge controller works is that no matter what the voltage that is coming from the sun, if your battery capacity is listed in any of the voltage that is being slashed on this controller, it will synchronize it with the voltage of your battery. Let's assume that you are having a battery system of 24 volts and you got a controller, maybe 30 amp, 12 volts, 24 volt, 48 volt, and 96 volt. Once 24 volt is listed in its specification there, let's assume you now arrange your panel to be giving 48 volt from the rooftop. When you get to the controller will convert it to 24 volt. It will make it adapt to your 24 volt battery system, and it will continue to be, it will begin to be charging it. So that is charge controller. Then let's talk about solar panel. Solar panel evolution came into being around 1957. It came into being around existence around 1950, when ISC scientists discovered that there is a silicon material that, if flip under the ray of the sun, is through their analog through their meter, is giving a deflection which indicates that there is a voltage supply. Then immediately they collected the silicon material specimen and research started, which give rise to evolution of both monocrystalline and which give rise to evolution of both monocrystalline and polycrystalline solar panel. What do they mean by monocrystalline and polycrystalline solar panel? First of all, let's imagine how they turn into a silicon material picked from the soil to a fabricated fine array like this that we can see as a solar panel. There are a lot of processes that took place after collecting the silicon material. They process it, take it to the factory, process it in different form, and they now fabricated into fine PV array like this. So during the grinding, smoothing everything, they extract the pure material of that silicon. They use it to make a panel. Then they later discovered that the residue that they are throwing away, which has impurity, that is not pure, also can be is also generating voltage. So they now started using that one with impurity again to form panel. So the one with pure silicon material is monocrystalline, while the one with impurity is polycrystalline solar panel. So we can relate it to the meaning that mono means pure, one, that is only that silicon material. When they extract all other impurity, monocrystalline. Then polycrystalline, that it contains impurity, polycrystalline. So they found out during laboratory tests, they found out that the two are efficient. Why the mono is very efficient in cold region, why the poly is very efficient in the hot region. And mono quickly generates current with the slightest light reflection. It gets, but poly, we need a lot of sun rays to begin to generate current. So poly is not that efficient in cold region, but mono is efficient. So this is a typical poly. This is a typical poly solar panel. You can see how do we identify them is the pattern of the cell. You can see it is arranged straight like this. The pattern of the drawing on the board face, on the panel face. So I will do a demonstration. I will still attach a work drawing on the difference between the mono and the poly solar panel, that is monocrystalline and polycrystalline solar panel. So let's go ahead. Then the kind of solar panels and solar panel that we deal with, it is rated in watts. It is rated in wattage, because the unit of power is watt. So when you are talking of solar panel, then you will be asking, what is the wattage? How many watts is the solar panel? The kind of solar panel that we have now, that is being produced now, apart from the small one they use for street lighting, the one that we use for domestic and industrial installations start from 80 watts, 100 watts, 120, 150 watts, 180 watts, 200 watts, 250, 300, 350, 400. Then we have, as of today, we have 450 watt panel. Then the specification of the voltage of this panel differs from 80 watts to 180 watts. Now, from 80 watts panel to 100, you should know that they are in 12 volt configuration supply. Then from 200 watts to the 450 that they are having in Nigeria now. Outside, you have something like 500, 600, but in Nigeria now the highest solar plate that we're having, solar panel, is of 450 watts. So from 200, they are of 24 volt configuration. They are of 24 volt configuration. But what you will see on those panels is their open circuit voltage. And open circuit voltage used to be higher than the normal on-load voltage or normal configured voltage for that particular panel. For 12 volts, you will see around 18 to 22. Once you get to, so from for 24 volts, you will see between 34 to 42. Those are 24 volt panels. So in terms of volts, that is what you have now. It's either you have 12 volt configuration, which is in the range of 18 to 22 volt, or 24 volt configuration, which is in the range of 34 to 42 volt open circuit supply. Then let's go to charge control. Yes, we the charge controllers, arms and volts. As I've said before, we have solar charge controller of 10 amp, 20 amp, 30 amps, 60 amps, 80 amps, and so on and so forth, which various voltage adaptation. Solar charge controller can adapt with multiple voltages like 12, 24, 36, 48. So no matter the voltage of your battery bank, once it is listed in the voltage of the controller, it will definitely adapt to it by itself automatically. Then let's look at different type of panel. Yes, which I've discussed just now: the monocrystalline, the polycrystalline. Then it comes in different wattage. I said starting from 80 watt to 450 watt for industrial and domestic large scale installation. Then let's go to panel positioning and angle. We don't just take panel and begin to arrange it on either solar structure or our roof. You know, in terms of placing on the roof, what you just need to take note of is the direction that the panel will face. You will need a hand compass, or you will need a hand compass in getting this right. You know, Nigeria is in the northern hemisphere of the earth. So with your compass, you will see the north, south, east, and west. So your panel in that rectangular form, the breadth side facing up, the breadth size. You know, a rectangle, the panel is in the form of a rectangle. It has length and breadth. So with your breadth facing up, so the panel in this part of the wall supposed to face the south, because Nigeria is in the northern hemisphere. So your panel is supposed to face the south. The breadth up, the two breadth side up and down. I hope you understand me. Now, if you are in a location that is at the southern hemisphere of the earth. If you check the globe, the yes, you will see Nigeria is in the northern hemisphere of the earth. So your panel should face the south. If you are in the southern hemisphere of the earth, your panel should face the north. That is it. Then let's discuss and then another thing is that you shouldn't lay your panel where anything will shade it. You should avoid any shades, either of tree, another building, or anything that will cover the face of that solar panel. It will not make it to function efficiently. It should have free access to reflection of sunlight. Then the tilt angle, though in the case of mounting on a home roof or building roof, you don't have option on the tilting angle. It depends on how the roof is being positioned. What you just need to master is whether it's facing the south. Then if it is on solar structure, if they want to arrange it on a solar structure like car park or a special structure built on a solar panel, you should be able to master the tilt angle of that panel. That is the angle at which the panel is being positioned, like this, the angle at which is being positioned to face the sun or the south. So normally in Nigeria, and your tilt angle should be in the summer. It should be 15 degree minus latitude. Why in the winter it has to be 15 degree plus latitude. So, and Nigeria here, we are on latitude 9.0778 degree north. So the correct tilt angle for our solar panel in the summer should be 15 degree minus 9, which is 6 degree, and it should face south. Then in the winter, during the rainy season, your tilt angle should be 15 degree plus latitude, which Nigeria latitude, which is 9.0778, which should be 24 degree, and it must face south if you want it to function efficiently. The reason for this tilt angle is that the efficiency of that panel depending on amount of light ray from the sun that is able to strike the face of that panel. So for you to get maximum sunlight that strike that panel, it has to be at these two angles, 6 degree in the summer, 24 degree in the winter, as far as Nigeria is concerned. So let's move on to panel series and parallel connection. I will still demonstrate this as time goes on. Yes, panel has positive and negative terminal. Yes, if you have two panels and you connect the negative of one to positive of the other, you have just made a series panel connection. And if you connect a positive of one to the negative of another, you should not connect the positive of the second one to the positive of the second one. Otherwise, you will get a short circuit. Because by you connecting the positive of one to the negative of another, you have turned the two panel to a single panel. Then for parallel connection is the connection of positive of one panel to the positive of the second panel, then negative of the other panel to the negative of the second panel. This, there won't be problem. Yes, one group to the same group in one panel, another one group, because minus begot minus, positive begot positive. That is parallel, and there won't be any short circuit or breach or problem. But if you connect the negative of one panel to the positive of the other, which are not in the same group, then you now want to do the second one, there will be problem. There will be short circuit. So, and that one we call it series connection. Then the one where each similar group are connected together, positive to positive, negative to negative, is parallel connection. Then there is something peculiar to the two. For the series connection, the voltage, since you have turned the two panel to one, if one panel is 12 volts, the second panel is 12 volts, and you connect the negative of one to positive of another, by the time you measure your voltage from the positive of one and negative of the remaining terminal, you will get 24, and each panel was 12. So in series connection, the voltage increases while their current remain the same. Whereas in parallel connection, the voltage remain the same. That type where you put positive to positive, negative to negative, the voltage remain the same while their current double. So the scenario where you will use the two, you will understand it better when we get to site. Then let's go to panel mounting. We don't just go to the roof there, then just look for any available space to tie our, no. First of all, when we get there, we look for where there will be maximum. You have learned that of you have to first, wherever you are, use your compass to locate the north and south, east and west. Then look for a convenient position where your panel can face the south of that place. Then when you get to the roof there, we have different accessories that will make our installation perfect. We have the you will get familiar to most of them when we get to site. We have the solar mounting rail, we have the L foot, we have the M clamp, we have the end clamp, then we have the grounding clamp, then we used to need flash band in case of any water is very porous. Water can easily find its way. So the point that we are going to nail to the rasters. The rasters are where the roof woodwork technicians lay their plank. You will see their nail straight along that raster. So while nailing our own L foot that will hold our mounting rail, there is a way we had flash band so that there won't be leakage. So Then the type of solar charge controller, we have MPPT solar charge controller, that is maximum power point tracker. Then we have PWM solar controller, pulse width modulation solar charge controller. The difference between the two is that maximum power point tracker solar charge controller amplifies the current gain, the current gotten from the sun much better than pulse width modulation solar charge controller, which make MPPT more efficient and more powerful than the PWM solar charge controller. But not that the PWM solar charge controller also is not efficient, but the efficiency of MPPT is more superior than that of PWM solar charge controller. Mono and poly solar panel. This is the way we normally identify them. On the solar panel array, you will see the one that is arranged serially like this. As at today, this is the identification mode. Are they arranged serially like this, like this, like this, like this? This is poly. This is polycrystalline. This is polycrystalline. Why the one of mono? You normally identify it like this. You will see it like this. You will see it this way. All these spots with the line are normally drawn with white, white material. Then like this. Then so any panel you see in this form is known to be a mono. This form like this is the way we normally identify it. This is the way we identify it. This is number one point of identification of mono solar panel. This is the number one point of identification of a mono solar panel. You can see it like this. Then the two of them will now have their positive and negative outputs. Positive and negative outputs. Poly, then monocrystalline. Then another way of identifying them is that if you take the two of them to a under the roof or a shaded area, the one that will still give you some level of current, when you bridge when you briefly bridge this positive and negative together, then you clamp your DC ammeter on it. The amps will be higher, it's going to be mono, while the one that the amps will be lower will be poly. So this is how we identify polycrystalline and monocrystalline solar panel. Thank you. Series and parallel panel connection. Let me briefly say this caution before I continue, that Start Powertech Limited will not be responsible for any damage or any injury incurred by anyone that is not a technical person trying to practice this without proper supervision of a technical expert. So the series connection of solar panel. Let's assume this is a solar panel with positive and negative. This is another panel with positive, negative. The series connection will be from negative of this to positive of this. By so doing, you have made these two panel one. Then the negative here, positive here, when you now measure it on your, when you use your multimeter to know the output, then the output will now be voltage of this plus voltage. If this one is 12 volt, this one is also 12 volt, you will now be getting 24 volt here for series. But if this is 3 amp and this is also 3 amp, what you will still get here is 3 amp. That is according to the Ohm's law, basic law, and it is practical. When you connect it in series like this, the voltage will add up while current remains the same. It has uses in arrangement of panel when we are doing installation. Then parallel, let's check the way we connect parallel. So this is a panel now, positive, negative. This is another panel, positive, negative. Let's assume they are 12 volt, 12 volt. Then if you want to connect in parallel, you connect in parallel like this. Negative of this to negative of this, positive of this. You can see I jump it to negative, positive of this. So positive to positive, negative to negative. So if you now want to choose your, this is negative. If you want to choose your output now, you can choose your output here, positive here, negative here. You can also choose this negative here, positive here, all the same, all the same. You can likewise choose this here like this, positive here, negative here, or positive here, but we don't encourage this because of equalization during charging and discharging. Current will be more concentrated on one battery and the other. That's why we choose positive on one battery, we choose negative on the other battery. So what you will now get at your output will be 12, still the same 12 volt, but if they are 3 amp, you will now get 6 and 3 plus 3. You can see for series, the current add up, the voltage add up while current remain the same. For parallel, the current add up while voltage remain the same. Please try and subscribe, like, and share our YouTube channel to help us improve in the dissemination of knowledge. Thank you.